panel today.
Randy, thank
Thanks,
you.
Robbie.
Really good job.
Super. I'm going to invite our innovators and developers up to the stage now. I think this has just been a great morning. We've gotten to hear from the communities. Now we're going to hear from the companies that are developing this technology and looking to site it around the country. I have the unenviable task of making sure that we get through 8 speakers in 1 hour so that we can get to lunch. So I apologize to our speakers. We have a big timer, and I'm going to hold you to an 8-minute limit. But really, the purpose of this discussion here is really a showcase so that you have an opportunity to eyeball these guys and meet the folks that are really on the cutting edge of advanced nuclear technology, get to know the types of technology that they're working on, and then have an opportunity to talk to them during the breaks, during the lunch that we're going to break into, at the reception tonight. So you guys can come on and get seated. We've got you in the order that you're presenting, which was alphabetical. And so we're going to move through this session really fast, and you're not going to get all your questions answered. But you can save those, and I encourage you to meet and greet at your leisure throughout the day. So we're doing this rapid fire session today in part because we've been really fortunate to have some dignitaries with us this morning with Dr. Goff, and then we have Kristen Ellis is from DOE here today, and she's speaking during lunch. So that's why we're really working hard to stay on schedule so that we can accommodate the DOE folks who went to some effort to get here. So with that, I would like to introduce Richard Williams, who's the Director of Engineering from ALO Economics. Oh, Atomics, sorry. Too much economic talk this morning. It's on the brain. There you go.
Thank you. Do I just press now and go, or? Okay. Yeah, I'd like to first thank the Energy Communities Alliance for inviting us to participate in this. It's ALO Atomics, just everyone says it differently, but it's just ALO Atomics. Our co-founder, when he was a child, had a difficult time with keeping lights on his house, and so the Bengali word for light is ALO. And my name is Richard Williams. I'm Director of Engineering. I'd first like to thank Mayor Casper and also Bear Prairie, who have been very, very supportive of ALO Atomics, as well as the DOE Idaho. They've been super supportive. Everyone, I think, knows this. Nuclear is hard. Big projects are hard, making the two very, very hard. We wanted to solve this problem by going to small, iterating small, deploying rapidly, and learning quickly. So rather than doing 10 or gigawatt in 10 years, our goal is a gigawatt in 1 year with 100 reactors produced. Well, so our timeline, actually someone challenged or said something about transparency earlier, and this graphic we made about 1.5 years ago, and it's stayed the same. It has not changed. Thank you. So we started in 2023 with a fund, Series A, or seed fund of $6 million. That allowed us to start the team. And then last year we completed our Series A for $30 million, which allowed us to grow and move into a new factory. And this year we're already started on our Series B, which is $100 million, which will allow us to grow into our ALO-X, and then eventually we'll go Series C, which will allow us to do commercial deployment by 2029. There we go. So who are we? We started with the Marvel. Some of you might have heard of the Marvel Reactor Project at INL. Our team, essentially once we got through DOE authorization, we immediately started working on the ALO-1. And one of the difference, there's some similarities between Marvel and Allo. The biggest thing actually is the team. A lot of those team members, including myself, have learned a lot of lessons in Marvel, and we're applying it today. I won't go back. This is our factory. We just started this factory in last August. We moved in, and this is us setting it up, as well as the equipment and video that we're creating. We'll have the full capability of producing essentially 30 reactors and all the equipment at this factory. And eventually we'll move into a full-fledged factory where we'll do 100 reactors per year. And we just had a reveal. I'll show you a video from that reveal a couple weeks ago. So we have the all-in-one reactor, which is essentially a 30 megawatt thermal, 10 megawatt electric reactor. And what we realized is that's not our product. Our product is a 50 megawatt thermal or 50 megawatt electric power plant. So we've got 5 reactors combined steam into a single turbine, 50 megawatt turbine. And the idea is that we can provide power for those centers that are limited by supply. We just talked about that. We can come in and we can set these up rather quickly and provide power. And this is just a sequence of how we see that happening. Transporting from the factory, excavating at the land, placing our reactor, and we actually are going to refuel our reactor or fuel our reactor at the site rather than bringing a fueled reactor in site. Placing all our equipment, including our secondary, in modules, and then repeating that 5 times. So the idea is, again, iterate small, repeatability, and deploy rapidly. And this just shows you a 200 megawatt plant. And this is the XMR. What we're titling is XMR, extra modular. So not only the reactor is going to be built in the factory, but all the components that are associated with the reactor, the secondary system, steam generator, all that will be produced in the factory. And our first project is going to be at the INL. It's Allo-X. We just completed our CDR, our conceptual design, with INL, and we anticipate going into construction, starting construction next April. And with this construction and the process with DOE, we understand that process being from Marvel, being associated with the DOE. So we're going to use that information, plug that into our NRC license, and help accelerate that NRC license. And this is just the leadership team. And again, Matt and Yasser have done an extremely fantastic job on hiring some great minds from across both industry and just tech and capabilities. But most importantly, it's probably our team. So in October of 23, we were 5, and it was 3 weeks ago, we were 50.
We should be deploying as much nuclear as possible, as fast as possible.
And this is from our reveal.
And the question is, why are we not building more of it? Is because of a fear of cost and schedule overruns. So what is the solution? We'll make mass manufactured nuclear power plants a reality. So we believe that the AI data center movement will be the big unlock for the nuclear plant factory vision. What is the optimal product to power the growth of AI? We are introducing a revolutionary new product.
So today is not just a pivotal moment for just Alo. It's also a pivotal moment for the great state of Texas and the overall United States nuclear leadership. Ladies and gentlemen, I am thrilled to present to you for the first time ever our full-scale Alo-1 reactor prototype. We just showed you the reactor, but it's not just the reactor. We can build all of the various modules of the pod in a factory setting. Our plan is to achieve less than 90 days to build an entire pod of 50 megawatts electric.
So it might sound obvious, but it's incredibly impressive to see what can happen when this is done right.
If this journey continues, then the many things that were not being built right, powered right, advanced correctly in this country, those are the goals that are just the starting stakes for what we're going to get right when we see Alo succeed.
Thank you.
Thanks very much. All right, so we're going to be switching back and forth for you guys on the timer. So you can see your slides, and then when you get close to the end, we'll try to bring you back. So thank you, Richard. Stop, Richard. Talk to him about the mobility of these new designs. It's really exciting stuff. I want to introduce Travis Chapman from BWX Technologies. Take it from here.
Great, thank you. I appreciate having the timer in front of me. I love nuclear energy. I would just keep talking about it as long as we could. So let's see here. And for my panelists, green button is forward. Yes, all right. I'm Travis Chapman, pleased to be here, privileged to share some time with you this morning. Come from BWX Technologies and one of our subsidiary groups, the Advanced Technologies team in Lynchburg, Virginia. From a Energy's Community Alliance perspective, it is great to be in Idaho Falls. In my time as a federal employee, I got to visit many of the DOE sites. Our company operates and manages many of those sites right now. Every single one of these is great. The communities are wonderful, the hospitality, I love visiting your restaurants, I love sending pictures to my family, and I appreciate Matt Solomon in the previous panel. We talk about the data centers, right? The data centers are coming, and I remind myself that those data centers are my puppy videos right now. We have a new puppy in the house. My wife daily is uploading minutes of video footage, right, that we will come back and look at later on in life. The data centers are critical to my family. Certainly, in many ways, probably they don't always understand. So, all right, BWXT, we've been around for a little while. We do some things, and very proud of the history that we get to share. As a company, our core business has been supporting the Navy principally and producing the reactors for the submarines and aircraft carriers in our fleet. So in a way, right, we were one of the original small modular reactor developers and producing them in a factory setting. We do that right now across a range of facilities and communities, non-nuclear components coming out of Barberton, Ohio, and the Euclid site up closer to Cleveland, Mount Vernon, Indiana, recently acquired Jonesboro, Tennessee, Fuel in Irwin, Tennessee, many of those being integrated at our Mount Athos site in Lynchburg, Virginia, and it's great to be in that community now. I've been there for a little more than a year, but to get to see a community that's grown up around a core business, BWXT and Framatome both have headquarters there, strong part of the community, our workforce comes from there. The number of folks that I run into in the advanced technology side that are graduates of Liberty, University of Virginia, the local area, it's just the most common story that you get to hear, and to see that community kind of revolve around the business has been great to see. As you can see, 415 reactors produced. There's a really great billboard in our factory at the Mount Athos site that has a little placard for every reactor we've pushed off the line, and we've been in the nuclear industry for about 70 years. So that perspective I think about from time to time. I worked for several microreactor developing companies. I've looked at these concepts, SMR deployments, things of that nature. We've been doing this probably the longest. In over 70 years, we've produced little more than 400 reactors. Sometimes our facilities, we have higher capacity when needed. That has happened in the past. You can see from the appropriations bills how many submarines, aircraft carriers we appropriate. It gives you an idea about the size of business, kind of as it stands. So we can say there is success in factory producing reactor systems, getting those delivered to customers. It's been a good business for us, and we're very proud to be a part of it. Large company with the acquisition of Kinetrix that should close this summer. If I remember right, we're going to push closer to 10,000 employees in between the nuclear operations group in Lynchburg, doing the Navy business, as well as our commercial division up in Canada that produces many of the components for the small modular reactors that are coming down the line. TerraPower, the BWRX-300 from General Electric Hitachi, several of the Natrium components, very large manufacturing capability up north that we support, as well as supporting those DOE sites across the complex. As a company, as I said, 75 years of nuclear history, but we've been around for about 150 years. Many boiling systems, coal fire power plants. You'll see B&W stamped on the components. Been doing this for a little while. And all of that heritage of heavy manufacturing, innovating on those components, producing them at high standards of quality, delivering them and maintaining them, certainly has underpinned all of our successes. More recently, over the last, say, 10 to 15 years, one part of the business that is now advanced technologies has largely been kind of the research and development arm for the company. Taking some of those investments, going and finding opportunities where we can leverage partnerships with governments, with states, with commercial interests to compound the value of those dollars and look at what are the next things that we could be working on. And in our case, my part of the business works on some of the most cool stuff, and we're going to share a little bit about that. I am going to stay on this view graph for 1 second longer because one of those programs, I don't have a visual for later, but we do have it here. I was on the panel yesterday, Ask Me Anything, non-nuclear, non-electric applications of nuclear energy. One of those is propulsion. Clearly we use it for the submarines and aircraft carriers. I was a submarine officer. Those are the Ferrari of reactor plants. They come with the Ferrari price tag, and the Ferrari fuel you probably don't want to go out and buy. So in many cases, we're looking for other solutions, but some contexts do require that level of performance in the machine, and the space environment is one of those. For our powering exploration, powering satellites, powering future lunar or Martian surface missions, space nuclear energy is a critically important part of our domestic national security. NASA, Department of Defense, others actively developing those technologies. We're proud to be a part of that through several programs, including a nuclear thermal propulsion unit. Across the business lines, spoke briefly about space, about our sea power side, but on the terrestrial side, there's been a lot of interest, especially from the government, in applications for nuclear technology that can support defense missions, potentially other kinds of missions that we've gotten to support. We have one part of the business that does nuclear medicine, radioisotope work. It's more of a commercial focus area. But we're going to stop briefly and talk about military applications and some commercial applications. But before that, why don't we stop and talk about fuel? Because fuel powers everything and you kind of need it. So one of our core strengths at the Lynchburg site, we have one of the largest capacity lines that can produce coated particle fuel. We call it TRISO fuel for tri-structural isotropic. Just means they take a tiny kernel of a uranium carbide, uranium nitride, some alloy of uranium, sometimes uranium oxide, coat it multiple times, becomes really, really strong, very tolerant of high temperature events. So if you have an upset condition, the fuel does pretty well. We produce that right now. We're hoping to scale that up in partnership with our friends in the state of Wyoming with the project that we have going on. So advanced fuels lead to use in advanced reactors. Project Pele is a defense-funded reactor development program to field a transportable microreactor. This is in the range of 1 to 5 megawatts electric. I would say as a nuclear engineer and by background, microreactors are by far the hardest engineering problem I've ever seen. You are fighting physics, and physics is not your friend. The materials need to tolerate very challenging conditions. They need to operate for long periods of time. And the operational context for this device is fuel it at the factory, deliver it, operate it, take it back, manage it. All of those things are very hard to do. So Credit to all of the developers that are trying to work through those kinds of solutions. We're very proud that our fuel for that device is finished, and assembly is happening this year for deployment here at Idaho National Labs. And then lastly, I'll leave off with a partnership, again, from the community engagement side. We engage heavily with the states, and in particular the state of Wyoming, often an opportunity through their the Wyoming Energy Authority for a cost share to work on, could we commercialize a version of Pele, bring that forward into the community. That activity's been going on for a few years now. One of the best parts about that opportunity has been community engagement and looking at where is the supply chain in these communities. And I can tell you in the state of Wyoming, there are some fantastic machine fabricators. They can roll steel, they can pull cable, they can cut graphite, an incredible capability supporting their mining and the production industries that we see as a future to leverage as the nuclear workforce needs grow, just the capabilities grow. States like Wyoming certainly are poised to take advantage of that, and as a state are investing in those capabilities and kind of marrying up the nuclear with the traditional industries. So with that, thank you for your time, and I guess we're going to stand by for questions later on.
I'm going to introduce Robert O'Brien, and I want to encourage everybody, you get to look at our speakers while they're up here and while they're speaking today. We're going to move from this session into lunch, so sit with these gentlemen. They are rushing through their material. They have lots more to say. Travis, I think you're right. We can all talk about these topics for a long time. But first, I think BWXT was a great introduction to our next speaker, Robert O'Brien, who's the director of the Center for Space Nuclear Research, which is an area that we haven't talked too much about yet today. So, Dr. O'Brien.
Thank you. Well, good afternoon. It's great to share some of our perspectives. Very briefly, I represent today the university's Space Research Association. It's a organization that was founded at the height of the Apollo era, again encouraged by the then NASA administrator, James Webb. We have 121 member universities, and innovation is the lifeblood within universities, and it's also the catalyst to success in industry. And it's that I think brings relevance today, and I'll explain why I'm here to perhaps answer questions about how we can continue that relevancy with space technology. So we've explored the near-Earth space system. We've landed on the moon. But we need to do the next thing, and that is to help commercialize space. And that goes beyond access to space. It's beyond initial communication technologies like satellites, smartphones today that are slowly evolving to be connected to the space environment with technologies like Starlink and other follow-on technologies that are coming and emerging there. Space exploration is exciting. It's a catalyst for innovation. It's an attractant for talent. And as we try to do very difficult things here on Earth, we need the best and brightest to engage those brain cells and the techniques and all the knowledge that we've solved for space can be applied to the terrestrial challenges. And with that, I will note that the microreactors that we're exploring today have a lot of lineage to space exploration. SNAP-10A. 60 years ago, SNAP-10A was flown, and that's a microreactor that was developed to enable propulsion and power to operate in space. And as we think about what's next, it's about space manufacturing, harvesting the resources that are around us, leveraging everything for our success in Earth orbit, to do more than just Earth exploration and this cislunar space exploration, think about Mars and beyond. We're going to have to harvest the resources that are around us, and ultimately, all of these things depend on energy. And that's the parallel and synergy to rural communities that we have, the challenges that we have. Space exploration requires detailed architecture, science, and engineering that all marries together beautifully to give us the ability to harvest energy efficiently and sustain the life cycle. If we think about resource utilization, taking minerals from the lunar dirt, turning it into silicon wafers, or building spacecraft structures from the lunar dirt itself, new alloys. There are programs that NASA and DARPA have sponsored. I think companies in the new space environment, startups, that are looking at these challenges, leveraging energy efficiently to make products of tomorrow that can enrich life on Earth. And I think that parallel is something that's very exciting. So to provide a fantastical image of what the next 50 to 100 years of space operations and manufacturing in space looks like, this is an artist's impression of what we can do in space, providing in situ resource utilization to power and sustain life and operations on the lunar surface, to do the same on Mars, but also return products to Earth, enriching life through better communications, cheaper communications. The energetics of getting to space and putting assets like spacecraft, communication platforms into orbit relies on lifting from the Earth's surface, and those energetics are not favorable in the long run. And so taking and using the resources that we have already in space, I think is a very interesting prospect, and I think we're going to see more materials and spacecraft systems built on the lunar surface, placed into Earth orbit, that is absolutely going to enrich life. And then if we think about the rare earth use, if we look at it, electrification of vehicles and the challenges of growing grid demand for manufacturing, where we source our rare earth materials and other critical minerals, there's a whole universe out there. And the moon provides another analog to extracting difficult to extract materials on Earth. If we can solve those problems on a bench scale, on a pilot scale for the moon, we can bring those back to Earth, bring them to your communities, and help us extract the materials that are distributed across the planet, but do that within our own borders and perhaps solve some of the geopolitical challenges of tomorrow. So innovation is the lifeblood, and as a history of some of the things that our organization at USRA and the Center for Space Nuclear Research has done, we've done a lot since its short history in 2005, where it was founded here in Idaho Falls, to help accelerate and bring the community of practice together for nuclear energy and the space science community to help us accelerate some of these technologies. We've worked hand in hand with industry. We've provided lean solutions to innovate and provide access to advanced manufacturing, advanced materials that are absolutely cutting edge and critical to access some of the energy solutions of tomorrow. Most importantly are the people, and encouraging people of tomorrow, the leaders of tomorrow, to build a future, to build companies, to accelerate small businesses. That is going to be absolutely critical that we sustain that moving forward. So I hope that when you see the parallels of what can be done in space, how we can leverage it, just remember that it's the workforce that will deliver that. And so hand in hand to solving difficult problems, we can inspire the next generation of leaders to solve these very difficult technological problems. We have a program that's entering its 20th year of operation here in Idaho, but working alongside industry partners, solving and providing access to knowledge and experience that can't be taught in the traditional university settings, and is very difficult to do on a production floor, for example. So by leveraging a lean environment, we've been able to put a program together that supports workforce development, working in partnership with our university partners, like Idaho State University. You'll see some of the images on here with critical experiment experiences that can be built and really leveraged to enhance that knowledge base. I think there's a very exciting prospect with nuclear energy in space. I think that same excitement translates to prosperity here on Earth. With that, I'm going to hand over to our next speaker, but thank you for having me. Thank you.
So much, Rob. I really appreciate it. That's great. So join Rob if you want to hear more about space mining and the nuclear applications that we haven't talked as much about. I think there are so many different companies, and Ed McGinnis, if you would like to join us next to talk about Curio. I think there's a clicker is up here. And I think Curio is another opportunity to really see the diversity of applications and the real innovation that's happening in the space right now. So I'll leave it for you.
Thank you very much. Pleasure to be here. I'm going to cut to the chase because in the interest of time, I wanted to hit one of the core issues that was addressed in the previous panel, and that is, what are you going to do with the waste? That is, in my view, the single greatest barrier and ball and chain to efforts to move and build new nuclear in the United States. It's also the single most misunderstood and undervalued sector within the broader nuclear sector. So what are we looking at right now? We're looking at the size, the scope of the problem and the opportunity. We have about 90,000 metric tons scattered around in over 80 sites, co-located with nuclear reactors, some where the nuclear reactors are no longer there, and the material is stranded. Stranded because the U.S. government tried, as we have, I was part of that process, I have tire tracks on my back trying to deliver on Yucca Mountain or under President Bush, GNEP trying to establish a closed recycled fuel cycle. Neither one of those worked. And so now where are we? We have stranded material throughout the country. What do we have with that legacy? We still have 12 states in this country that has legislation with moratoria, either barring or limiting nuclear deployment, primarily because of the waste. So it's a pretty simple issue. It's right in front of our face, and it is an issue that's not going to go away. But here's the good news. I said it's one of the most misunderstood aspects of the nuclear sector. It absolutely is. We did not stop reprocessing or recycling in this country because we didn't know how to technically do it. We did it all the way back to Ford and Carter because of international security reasons and because of the process, the way by which used nuclear fuel in this country was going to be or was being recycled, which is the Purex process, which is essentially the same process being used around the world today. So what do we have? We have this, I think it's more accurate to say, slightly used nuclear fuel sitting around this country. There is enough energy value still remaining in this used nuclear fuel, according to the Idaho National Lab scientists, not me, to meet our electricity needs, the entire country, EVs and everything, for over 100 years. And that's just the remaining value of the uranium. So when used nuclear fuel or fresh fuel is run in a typical reactor in the United States, it's run for about 5 years, the fuel, before it's pulled out. Once it's pulled out, it's not used anymore. During that 5-year fissioning process, a plethora of highly valuable market isotopes are created. Not just plutonium, which is a very important second source of fuel to the uranium that's still resonant and they're ready to be used. You have medical isotopes, industrial isotopes. Did you know that there are some of the most expensive, most precious metals in the world, non-radioisotopes, that are generated during this process, like rhodium, the most expensive metal in the world? There is a huge amount, equivalent to about 10% of the world's annual demand, sitting in the 90,000 metric tons. This is not a waste. And it's not that we don't know how to do it. It's because of government policies over the years and then public perception in large part. So what is the reason why we don't have reprocessing in this country if there's such a compelling proposition? Number one, like I said, for the Purex process, the process being used around the world has an unacceptable security Trojan horse, which led Carter to ban it. And that is a pure stream of plutonium and maintaining hundreds of metric tons of weapons-usable plutonium, such as at La Hague. Very safe, very secure, but nonetheless, that has been a policy sensitivity that goes all the way up to today. Environmentally, nitric acid is used. So that is another major problem. It generates more waste than when you started reprocessing that material. So our company, we've decided to come with Curio with a clean slate and eliminate the use of nitric acid. It's a largely dry process. And when we do that, what does that allow us to do? It allows us, with a non-aqueous process, using a pyro process, including a deox and a fluorination and electrowinning process, part of it, really strong competency at Idaho National Lab, and also PNNL and Oak Ridge. Curio's partnered with 4 national labs. But by eliminating the use of nitric acid and using a pyro and electrolysis process, we believe we can actually get down to about 4% of the original high-level waste, separating out the low level and pulling out as many as 10 isotopes that have market value. A lot of them are major heat drivers and account for the type of size that you would need, such as Yucca Mountain. So number one. Number two, we've eliminated the pure stream of plutonium. We are going to pull out plutonium for fuel, but co-extracted with other self-protecting isotopes. And number three, all of the reprocessing plants around the world are state-owned. They're not hardwired for entrepreneurial minimum overhead, maximum ROI. We're doing that. So we're going to do a multi-commodity extraction approach, and we're going to pull out every isotope that has value. We have about 10 offtake agreements and indicators. And finally, beyond that, what we are going to do is we're partnered, as I said, with 4 national labs. We are barreling down now. We're close to concluding our 3-year lab-scale demonstration right here at Idaho National Lab using commercial used nuclear fuel, demonstrating this dry process where we can recycle it, get it down to 4%, and then multiple co-extractions, 4 different isotopes, and then also do it in a way where we don't pull out a pure stream of plutonium. We believe that builds in the policy priorities and addresses the historic policy priorities that have kept recycling largely from happening in this country. We're going to scale up. We have the largest nuclear fleet in the world, which means we have the largest amount of slightly used nuclear fuel ready to mine. So I know I'm running out of time, but just reinforce the volume, the process for our facility. We will have the largest throughput facility in the world, on the planet, but the most compact. So we are targeting recycling all 90,000 metric tons. That means we're going to have a facility the size of a modern football field and building and recycle 4,000, as much as 4,000 metric tons a year. We could work through the stock of 90,000 in about 40 years. And finally, the jobs generator and the economic driver. This facility will generate, we will have well over 3,000 full-time jobs, mostly trades-based, kids, great local access, high school well-trained, 2-year associates well-trained. We're proud of that 60-year facility. This will be a tech corridor and anchor. And lastly is the local benefit. Over $400 million, we estimate, from that facility going right into the state and local community. We're very proud of this. We're planning to have full commercial deployment in about 7 to 8 years. First commercial within about 4 to 5 years, and we're on our way now. So thank you very much.
Thanks so much. That's great. So if you sit with Rob at lunch, you can hear about mining from the moon. If you sit with Ed, you can talk about the mining we can do from our own nuclear waste. Really great stuff. And I just think we have a great mix of speakers today from both large companies and small innovators who are relatively new to the market. But Energy Solutions is a company that has a wide range of activities. And I'm happy to introduce David Campbell to talk about Energy Solutions.
So I'm actually not sure why Seth and Kara put me on this panel. I don't have a technology. I might be comedic relief. But I do own 2 reactors, so maybe that's why I'm up here. We are a services company, and we are known as a waste company, a D&D company. We've been around 30 years. We are critical to the nuclear industry. Our waste facility out in Utah handles 80% of the low-level waste in the commercial nuclear industry. Our clients include pretty much every nuclear utility across North America, plus nuclear companies internationally, utilities internationally, all the DOE sites, all the federal sites that have nuclear materials. So we do a lot in the nuclear space. We have a services side of the company as well that does front-end work, that construction, mods and maintenance at nuclear sites and things of that nature. We also are one of the leading D&D companies, commercial companies. We've done 8 reactor sites, successfully closed those. We have 4 active projects, of which we own 2 of those reactors, in which we transferred the licenses to us. So we are an NRC licensee. We own reactors. This is kind of what we look like. This is what people, the DOE community certainly know us. We find ourselves in a unique position because we also own nuclear. Besides owning reactors, we own other nuclear facilities, waste facilities, the Clive site out in Utah, numerous treatment facilities around the country. This map up here shows sort of our breadth of how we have a life cycle approach to the nuclear industry. It doesn't cover all the commercial nuclear utility sites that we're performing work or all the DOE sites. We take or treat or any number of things, waste from every DOE site as well. So, we're out there, we're working within the communities, many of the communities are here, and we find ourselves in 2 years ago in an interesting position. I would say I'm up here as a developer, a hesitant developer is what I would call us. About 2 years ago, we looked around, we saw what was happening, where the winds were taking the nuclear industry, and we said, you know what, we need to do more. We service our clients. Our clients are nuclear companies, nuclear utilities, technology companies. What can we do more? So we sort of pushed our way into the front end of the business. New nuclear is coming. We're all working on that here. We don't know exactly when. There's some projects happening. But we need to get on the front end of that. So we developed a front-end nuclear services business that works with the utilities, helps them with their uprate programs, their site renewal programs, things of that nature that is part of the evolution of the nuclear industry right now, going from 60 to 80 years operation of existing reactor sites, plus how do we get into new get the new business going. And so we looked around and we said, we need a regenerating business. We need one that allows us to help our clients think about their active programs that they have. How do they run their facilities more efficiently? How do they deal with their waste? How do they close their sites? Once a utility has a reactor that's shut down, it's a liability. They don't want to have it. So we have to move on. And then how do we help them get going? So what we decided and then what we started looking at is, we can be a developer. We own sites. We own TMI-2. So my question, why do you own TMI-2? That's not the greatest reactor in the world. Has a little bit of a history. Well, that helped us on the back end. That is our business, cleaning up sites, dealing with the waste. Also happens to be in the same island as TMI-1. We work very closely with our client constellation on numerous things. We share an island. There's opportunity there. We own Kewaunee in Wisconsin, which is, it was a 600 megawatt reactor that we're in the process of D&Ding. We have an NRC license. We own material. We own the site. But, it's 900 acres. Only 65 acres were used for the existing reactor. I'm sure more could be done there. So what we've noticed out, a lot of this meeting here, you have the communities talking about their interest in new nuclear. That's fantastic. But then you have the technology folks who want to use their technology. They want to sell their technology. You have the utilities who just want to be able to generate power. They don't always want to own it. Sometimes they just want to generate it. how do we bring it all together? And this is where we came up with our model, which is really as an integrator developer. And it's really about really trying to make sure every party works to their best interest, but works to their specific capability set. And how do we bring that together? And so, we're very much focused on accessible sites. And, there's been a lot of the discussion here. How do you make your sites more accessible? You need good communities who are interested, but you also need good states who are willing to push it along and help with the regulatory process, right? You need, we're technology agnostic. We talk to all the technologies. What might work best for our site if we're interested, or what might work best for the utility? Do they want to, do a data center, which might be more appropriate for an SMR, or do they want to put 4 gigawatts on a site? It's really about being open to help facilitate the process, and that's how we're approaching the developmental world of new nuclear. I talked to David Hill, Dr. David Hill, earlier today from Terrestrial. He's a longtime Idaho guy. He kind of nailed us perfectly. He said, everyone wants to be second. Well, you're right. We don't want to be first. There's a lot of people who want to be first. We're happy to be second. Again, the hesitant developer. We want to get there, but we want to get there right. And how do we get there right? I did a lot of development work in the 2008 to 2016 timeframe with solar and wind. There was, I called it braggawatts. There's a lot of braggawatting going on out there. Project. We don't want to do that. We want to make sure we're putting it together. And so when we're ready to go, we're ready to go. It takes a lot of conversations and making sure people's interests are all together. See that, focus with and collaborate with motivated stakeholders. That's really important because they're a big part of the puzzle. Technology is a big part of the puzzle. Who's going to be the owner? You got to be open to that. We are an owner of a reactor site. Do we want to be an operator? Not sure we do, but we probably want to be part of the solution overall, and so that's what that's what we look to. I'll just talk on this last slide. This is just things we're thinking about. Nothing's been papered, nothing's put on pen. We're exploring a lot of different things. We have a relationship with Terrestrial where we have an MOU where we're just exploring things. They're Gen 4. We like, again, going to, we don't mind being second. Let's look to see what can be done down the road. But we're talking to data centers, we've talked to Meta, Amazon, you name it. Those are all things we can look at. We're looking at, our own sites. What's the infrastructure? Do we have transmission? Do we have all those sort of things? And just assessing it. Multi-site, early permit, discussions with various utilities, because they're just also exploring. We're looking at coal sites. We've had conversations with coal sites about how we can, from a services perspective and a reactor owner perspective, help them because they don't know anything about nuclear. How do we help them get there? And then if you look at the sites we have, it's just for information, really. One is a dry site, that's the Clive site. Very good for Generation 4, probably. The other is Wisconsin. We're not out talking with the community yet in full. We talk to them all the time, but we're not sure we're ready to go do this, but we're exploring it, and I think that's part of what a developer needs to do is try to bring all the pieces together and make sure all the interests are aligned, and I'll stop there.
So much, David. That's really informative. And I think for all of the community members who've asked the question, like, where do we start? It's great to know companies like Energy Solutions, been in the industry for a long time and are looking to do that integrated delivery of projects. So they're looking at it more holistically than individual developers of technologies themselves. But moving back to the innovation front, Peter Okrasa
okay.
from the Pioneer Nuclear. So I'll let you take it on, Peter.
Thank you. So my name is Peter Okrasa. I founded Pioneer Nuclear. But before then, I just wanted to thank ECA and for inviting me to the Nuclear Forum here. This is great. Kara and the team, thank you. And it's my first time in Idaho, so it's almost like paying homage because I grew up in Connecticut on the Idaho potato. And our local market, only carried the best and the freshest vegetables, so my family swore by the Idaho potato, so I'll take Representative Simpson's offer all day long. Thank you. So I think the ECA also invited me because they're headquartered on Connecticut Avenue in Washington, D.C., I believe. So thank you. I believe that they have a sweet spot for me here. So I started my company in late 2023, a month after I visited Oak Ridge National Laboratories. So that's kind of like my first, I guess Oak Ridge took my virginity there for nuclear. And, I fell in love with nuclear because I saw the 80 megawatt reactor. It was my first reactor. It's a test reactor, I believe. And also that same day, I saw Frontier, the supercomputer, which I believe back then was the fastest in the world. Now it's been overtaken. And I became hooked. So I joined American Nuclear Society. And then after a few months, I don't know if anybody saw the movie Nuclear Now. Anybody see that? Yeah. So that's why, that's what inspired me to get into nuclear. And basically, I had no background in nuclear. So I got into the industry before 2023. I owned a life insurance brokerage. So it's kind of, but you can quote me on this. Nuclear energy is life insurance for the earth, if you think about it. So in 2020, I started reinvesting my insurance profits into angel investments into high-tech companies. And then in late 2022, my friend who's a VC investor, he invested into Radiant Industries. And it just blew my mind that I can actually invest into nuclear energy. So, I didn't even know that this is an investable asset class. And I started investigating it, and, I had an epiphany. I sort of looked at nuclear medicine and nuclear energy, was thinking which one I wanted to get into. And actually, I found out through my investigation that nuclear energy saves more lives, believe it or not. All right. How do you do this, the green? Thanks. All right, so I made a conscious choice to get into site development because, my background's not really into nuclear science, so I didn't want to get into technology developer, but this is the actual government definition from the recent solicitation. And, I didn't want to reinvent the wheel. Everybody knows that there's so many technologies out there. I didn't want to make another technology to, confuse us more. And I started collaborating with INL in November 2023. It was actually the same day that the UAMPS project failed. And I said, come on, guys, why is everybody so down? I said, this is just the beginning. So about that time, one of my friends, he's a data center developer, and I started seeing that data centers are going to need more energy, and that nuclear kind of fit perfectly for the data centers. So I started looking at leasing federal land. Kind of had this idea back in 2023. So I was speaking to INL about this, and I basically said, to INL, I said, if we don't provide the data centers, the hyperscalers in particular, the energy, they're simply going to go overseas. We're going to lose our American competitiveness here, so we have to I was kind of like the Paul Revere, sounding the alarm. So sites that we look at, I put here in yellow, Connecticut. Does anybody know what that site is? General Dynamics. That's where they make the nuclear-powered attack submarines. And I believe that we just christened USS Idaho this year, if I'm not mistaken. I don't know if anybody's into a few nuclear Navy people here. And I started, kind of reversing the state's stance. They were all in on offshore wind for some reason. And I said, here's a state, we have huge competency in nuclear. We've had nuclear since, I believe, the 60s. And I said, what are we doing with this offshore wind? This is crazy. So I reversed their stance and I actually got the governor, I got the state of Connecticut DEEP, which is the Department of Energy, commissioner to squeak out the word nuclear. And, I basically told the state, so in Connecticut, our state's called the Constitution State. I said, what are we doing here? Are we going to be around for the next 200 years? Why are we making a 5 or 10 or 15-year energy plan? And they basically said, you're right. I said, why not make a 100-year energy plan and include nuclear on this? So, so they took my advice, and, we're looking into that right now. Anybody see the wind turbines this morning on the mountains? They're like not spinning. Anybody? All right, so this is my market right here. So this focus on this, and just let it sink in. So 2024 is already last year. 2025, we're already looking at 41 gigawatts. This is a report that just, I believe this month came out from Deloitte. So just in the US, we're gonna need in like 10 years, 176 just to service data centers, which is insane if you think about it. And if you look at figure 2 on the right, reactivating or reconstituting closed down nuclear reactors, basically, converting coal sites into nuclear, basically doing anything that we can do that's in the liftoff report to squeeze out 60 gigawatts. That's just going to be a very small portion of what data centers need for the next 10 years. So, this is sort of like a call to urgency. And I don't know if anybody read the Goldman Sachs report last year. So Goldman Sachs said that like 2 to 3% of all US energy is consumed by data centers, and they're predicting like 10% by the end of 2030. So this is even more aggressive than what Goldman Sachs was predicting. So it's crazy. I don't know, does anybody know where we're gonna get this? Even nuclear is not gonna fit this. So this chart right here, if you go to my website, you can find it in the resources section. But if you focus on the right side of the chart, anybody see anything wrong with this chart? Anybody? All the under constructions in China, Russia, Egypt, right? There's like no, yellow boxes in the U.S. I believe that's like one yellow box in the U.S. now with Clinch River. So, so going back to my company, this is what we're focused on. We're going to be deploying it. We're also tech agnostic. We're not, too interested in technologies. To be honest with you, it takes a lot of infrastructure work. By the time you get done with the infrastructure work, you don't even know if the technology is still going to be there, frankly speaking. So we're looking at these solutions to, help the U.S. Stay competitive. And thank you, the state of Idaho and ECA. I don't want to stop anybody from lunch.
All right.
Appreciate
Thank
it very
you so
much.
much, Peter.
Thank you.
No, that's great. It's great to have a couple of technology agnostic presenters today to kind of give us the sense that there's so many different types of jobs and so many types of talent necessary for a growing industry like we have right now. We have our last speaker is Myron Kazmierski, and Myron and I have kind of trailed each other all over the planet working on nuclear issues, and it's great to have Holtec here to wrap us up in the session. We had one slight programming change. If you're wondering where General Atomics is, they will be presenting in the afternoon session. So,
great, Laura, thank you the very much, and thank you for the invitation to be here. I want to start off with a comment that Dave Campbell made, and we will be very happy to be first. And we're looking forward to it. I'll first provide a brief overview of a technical overview of the Holtec SMR 300, and then the status of the SMR 300 program at Palisades site in Michigan. Okay, this is a busy slide. I'll have a few comments on it. This slide provides a technical overview of the SMR 300. The figure on the slide shows the SMR 300 dual unit configuration on a 20-acre footprint. The SMR 300 is based on proven pressurized water reactor technology and existing light water reactor licensing. The SMR 300 has the highest power density of any light water reactor SMR in development today, which translates to cost effectiveness. The SMR 300 has passively engineered safety systems relying on natural circulation. There's no need for off-site power, off-site water, or operator action for shutdown. The SMR 300 has an 80-year design life for the non-replaceable components. It uses conventional off-the-shelf technology and components, including the fuel and the control rod drive systems. The SMR 300 is capable of fast ramp-up operation, dispatchable capability, and can be load following. Also designed with the option of air-cooled condensers for siting away from any sort of water sources. Provided in the lower photograph here is the existing Palisades nuclear power plant, which was acquired by Holtec in 2022 from Entergy for decommissioning and dismantlement. With the encouragement from the governor and the Secretary of Energy at the time, Holtec decided to restart the shutdown nuclear plant. The Palisades restart remains on schedule and on budget for planned operation in the fourth quarter of this year. For the SMR 300, we are executing a build, own, operate project structure. The upper figure on the slide shows the location of the 2-unit SMR 300 plant that will produce 640 megawatts of clean electric power. We anticipate a 2,000 personnel workforce during construction, 280 permanent long-term good-paying jobs during operation, and over thousands of long-term jobs created through local supply chain development. Some of the key milestones for the SMR 300 are listed on the slide, notably the limited work authorization and full environmental report that will be submitted to the Nuclear Regulatory Commission in January of 2026. The photographs on the slide show some of the current site clearing activities and boring locations to support the environmental report. We plan to start full nuclear construction in the first quarter of 2029, receive the operating license for Unit 1 in the fourth quarter of 2030, with commercial operation of the second unit in the second quarter of 2031. The dual unit SMR 300 will be located on the 20-acre protected area shown in this rendering, several hundred yards behind the existing Palisades nuclear plant site. We have completed the site master plan shown on these two figures. The construction sequencing and the pre-construction engineering work packages have also been completed. Also, the local permit plans and timelines for approvals are also in progress. On-the-site construction activities will begin after the Palisades nuclear plant restart is complete in the fourth quarter of 2025. I want to spend a few minutes on the licensing approach, which consists of the pre-application activities, briefings with the U.S. Nuclear Regulatory Commission, white papers, and licensing topical reports. We have several that are going to be completed at the conclusion of this year, and again, supported again by the license limited work authorization in January of 2026. We are following the 10 CFR Part 50 two-part licensing process, which consists of a construction permit application with the PSAR and the environmental report. The operating license application will include the FSAR and final safety evaluations that will consider all the as-built conditions. We also have taken advantage of the regulatory feedback from the generic design assessment that was performed in the United Kingdom. Holtec licensing approach substantially de-risks the project deployment. Having a standard pressurized water reactor technology and commercially available 5% enriched fuel that the Nuclear Regulatory Commission is familiar, supports this approach. The SMR 300 project delivery team is comprised of financially strong companies with proven track records in the commercial nuclear industry. Holtec is the technology developer and manufacturer of the largest capital equipment, is the largest supplier and exporter of nuclear equipment in the United States. Hyundai has constructed 18 nuclear plants in Korea and building 4 nuclear plants in UAE. Mitsubishi Electric has supplied proven U.S. NRC-approved INC control systems for multiple nuclear plants. Framatome is a proven supplier of nuclear fuel and will provide the standard 5% enriched 17 by 17 PWR fuel assemblies. At each SMR location, there will also be dozens of local suppliers. Holtec is addressing one of the more significant concerns regarding the supply chain supporting the emerging demand for small modular reactors and microreactors in the United States and globally by increasing manufacturing capacity for large components. Our existing manufacturing plant in Camden, New Jersey, pictured here on the slide, was designed specifically for the manufacturing of SMR components. It'll be upgraded to produce 2 SMR 300 units per year, and our plans are to build regional manufacturing plants that will provide 2 to 4 SMRs per year. A rendering of these larger manufacturing plants is located on the slide here that will include state-of-the-art automation and robotic welding. Another significant concern of our resurging nuclear industry is driving down the cost of building small modular reactors. We are competing with the cost of building new gas-fired plants that are, $1,300 per kilowatt versus the current construction costs of nuclear plants, which range from $6,000 per kilowatt up to $12,000 per kilowatt. A recent press release by GE Renova showed a testing of modular steel concrete building blocks for the nuclear plant, for construction of the containment structures at nuclear plants, to reduce the overall construction costs. We have designed a similar concept for modular construction of nuclear plants, containment enclosures, and reactor auxiliary buildings that are prefabricated in factory settings and assembled on site with robotic, field-deployed welding equipment. And finally, the SMR 300 on beautiful Lake Michigan. And that concludes the presentation.
Thank you so much, Myron. Thank you to all of the companies here. You guys pulled together really tight presentations for giving everybody here an opportunity to just get a taste of all of the different opportunities that are evolving around the country. So it's really great to have you. Thank you very much. We will break now for lunch in the adjoining room. And so I encourage everybody, don't be shy. These gentlemen worked hard to make their points in a short amount of time. They have lots more to say. And so ask them what they didn't get to say on the stage today. We'll keep the conversation going through the afternoon and in tomorrow. Thank you.